This code imports 3 different Python packages, namely pandas, numpy, and matplotlib.pyplot. By using the as keyword, it assigns shorthand names for these packages, making it easier to use and reference them later in the code. The first package, pandas, is used for interacting with files and obtaining data frames. This means that with pandas, we can load, read, write, and manipulate data files in different formats, such as CSV, Excel, and SQL databases. The data frames in pandas are powerful and allow us to perform various operations on the data. The second package, numpy, is used for algebraic operations. It contains powerful mathematical and scientific functions for working with multidimensional arrays, matrices, and mathematical calculations. NumPy is commonly used for data analysis and machine learning applications. The third package, matplotlib.pyplot, is used for data visualization. It provides functions and tools to create different types of graphs and charts to visually represent the data in a meaningful way. This package is often used in data analysis and data science to gain insights and communicate results effectively. Overall, this code enables us to use these powerful Python packages to perform various tasks like loading and manipulating data, performing mathematical operations, and creating visualizations. This can be useful for data analysis, machine learning, and other data-related tasks. This Python code uses the library pandas, which is used for data analysis and manipulation. The command read Excel is used to read an Excel file. In this case, the file path to the Excel file is specified as C users/documents/0001-financial engine 3 investment and portfolio file for FE523 homework data.xlsx. This means that the code will look for and open the Excel file located in that specific file path. Once the Excel file is open, it will be stored as a pandas data frame object, which can then be manipulated and analyzed using various methods and functions available in the pandas library. This code is useful for working with large datasets and performing data analysis tasks in Python. This Python code utilizes the pandas library to manipulate a data frame called df. The first line sets the index of the data frame to be the date column. This means that the dates in the data frame will now be used as row labels instead of the default numerical index. The second line creates a new data frame by selecting only the GARAN and AKBNK columns from the original data frame. Finally, the last line displays the first and last 5 rows of the new data frame using the head and tail functions. This allows the user to easily view the data and make any necessary adjustments before further analysis. This code uses the matplotlib library to plot a graph of the data stored in the data frame df. This data frame is plotted with a specified figure size of 16 by 5, meaning the graph will have a width of 16 units and a height of 5 units. The plt.show command tells the code to display the graph once it has been plotted. This allows the user to view the data graphically and make any necessary observations or analyses. Overall, the code is a convenient way to visualize and interpret data stored in a data frame using the matplotlib library in Python. This code creates 2 new columns in the data frame called log_GARAN and log_AK. The first column, log_GARAN, calculates the natural logarithm of the ratio between the values of GARAN in the current row and the previous row. This ratio represents the change in the value of GARAN over time. The second column, log_AK, does the same calculation but for the AKBNK column. It takes the values in the current row and divides them by the values in the previous row, then calculates the natural logarithm of that ratio. These new columns provide a way to measure the changes in the stock values for 2 companies, GARAN and AKBNK, over time by examining the log of the relative changes in their value. By comparing the values in these columns, we can see which stock experienced greater changes over time and make further analysis based on that information. This code is using a Python library called pandas to manipulate and display data. The code is specifically working with a data frame df and selecting 2 columns from that data frame, log_GARAN and log_AK. It then uses the dropna function to remove any missing or null values from these columns. Once the data is cleaned, the code uses the plot function to create a visual representation of the data. The figsize parameter specifies the size of the plot, and the 16.5 values indicate the width and height of the plot respectively. Finally, the pl.show function is called to display the created plot. Overall, this code is essentially displaying a graph of the data within the log_GARAN and log_AK columns of the data frame. This Python code utilizes the dropna function to remove any rows from the data frame, df, that contain missing or null values. This function is typically used when handling data that is incomplete or has missing values that may negatively impact any analysis or operations performed on the data in the data frame. By eliminating rows with missing values, the remaining data in the data frame becomes more accurate and reliable for further analysis. The dropna function is commonly used in data preprocessing and cleaning before diving into more advanced data analysis techniques. This Python code prints the correlation coefficient calculated between 2 return values, specifically log_GARAN and log_AK. The n ensures that the correlation coefficient is printed on a new line. The correlation coefficient is calculated using the core function from the pandas library, with the method set to Pearson and the minimum number of periods required to compute the correlation set to 1. This value measures the strength and direction of the linear relationship between the two return values, with a higher value indicating a stronger relationship. This code can be helpful in determining the relationship between two return values and predicting future returns. This code is performing correlation analysis on two columns, log_GARAN and log_AK, in a data frame called DF. The code is first printing a line of dashes multiple times in order to create a visual break before printing the results, which makes it easy to distinguish between the correlations for the first 1,000 and 1,500 days. The next two lines are performing the correlation analysis using the .core function and specifying the method as Pearson, which indicates that the correlation coefficient is calculated using the Pearson correlation method. The min periods equals 1 parameter ensures that the analysis is conducted only on valid data points, rather than including null values. Finally, the .lock function is used to specify the date ranges, the first 1,000 days and the first 1,500 days, and the two columns that are being compared. The results of the analysis are then printed, giving the correlation coefficient between the two columns for each specified date range. Overall, this code is useful for quickly evaluating the correlation between these two columns over different time periods. This code first prints a title for the scatter plot, specifying that it is a scatter matrix of logarithmic returns. Then, it creates a scatter plot using the matplotlib library, which contains two plots, one for the logarithmic returns of GARAN data and one for the logarithmic returns of K data. The code uses the pandas library to select these specific columns from a larger dataset and drops any rows with missing values. Finally, it specifies the size of the figure to be displayed and shows the plot. Overall, this code is used to visualize the relationship and distribution between the logarithmic returns of two different datasets. This code calculates the moving correlation between two variables, log_GARAN and log_AK, in a dataset represented by the variable df. First, it drops any missing values in the log_GARAN column using the dropNow method. Then, it uses the rolling method to calculate the correlation over a specified window size of 500 for the remaining values in the log_GARAN and log_AK columns. The result is stored in the variable moving correlation 500. The same process is repeated with a window size of 250, and the result is stored in the variable moving correlation 250. This code is useful for analyzing the relationship between two variables over time, and the varying window sizes allow for different trend patterns to be observed. This code creates a figure with a size of 16 by 5 inches and sets the title to moving correlation with 500 data points of returns. Then, it plots the values of the variables moving correlation 500 and moving correlation 250 on the figure, with a red line for the first and a blue line for the second. These variables likely contain data on the correlation between stock prices and a certain index or benchmark, calculated over a period of 500 and 250 time periods, respectively. The legend is then added to indicate which line corresponds to which variable, and the figure is shown on the screen. This code may be used to visually compare the correlation patterns over different time frames, providing insight into the relationship between stock prices and the benchmark. This Python code creates two new columns, log_PG and log_PA, in the data frame named DF. The first line of code calculates the natural logarithm of the GARAN column and assigns the result to the log_PG column. Similarly, the second line calculates the natural logarithm of the AKBNK column and assigns the result to the log_PA column. The purpose of doing this is to transform the price data of Garanti and Akbank into their logarithmic values. This transformation is commonly used in financial analysis as it helps to normalize the data and reduce the impact of outliers, making it easier to interpret and compare the prices of different stocks. This Python code uses the pandas library to plot a chart of the logarithmic prices of two stocks, log_PG and log_PA, over time. The DF log_PG log_PA selects only the columns related to these two stocks from the bigger dataset. Then the .plot figsize 15.6 function uses the data to create a visual representation of the stock's prices, with the x-axis representing time and the y-axis representing the logarithmic prices. The figsize equals 15.6 argument sets the dimensions of the chart to be 15 inches wide and 6 inches tall. The pl.title logarithmic prices of stocks function adds a title to the chart, labeling it as logarithmic prices of stocks. Finally, the pl.show function displays the chart in the console or the output window, allowing the user to see the plotted data. Overall, this code helps visualize the proportional changes in the logarithmic prices of the two stocks over time. This Python code prints the correlation coefficient of two logarithmic prices. The first part of the print statement outputs a string that includes the phrase logarithmic prices in bold. The 031im and 33.0im surround the phrase with formatting characters that make it bold. The next line starts with a comma, indicating that the print statement will continue on the same line, and then accesses a data frame called DF and selects two columns from it, log_PG and log_PA. The .core function calculates the correlation between these two columns using the Pearson method and with a minimum of one data point needed. The result is then printed on a new line. Overall, this code combines printing and data analysis to display the correlation between two logarithmic prices. SciPy is a library in the Python code language that contains various statistical and scientific computing functions. Within this library, there is a module called stats, which can be imported and used in the code. This specific line of code imports the stats module from the SciPy library, making its functions accessible to the rest of the code. The comment following the import statement explains that this particular module contains functions for linear regression, a common statistical method used for analyzing the relationship between two variables. Therefore, by importing the stats module from SciPy, the code is able to access and utilize the linear regression functions for the task at hand. This code uses the Python library matplotlib to calculate the slope, intercept, correlation coefficient R-value, p-value, and standard error of the linear regression line for two variables, log A and log GARAN, which are columns in a data frame named df. The first two lines assign the values from the columns to variables x and y respectively. Then, the stats.linregress function is used to perform the linear regression analysis on the two variables. The returned values, slope, intercept, r-value, p-value, and std_error, are then assigned to their own variables for later use. This allows the user to easily evaluate the strength and direction of the linear relationship between the two variables and determine the significance of the relationship. This line of code prints out the values of two variables, slope and intercept, in the format of slope. Value of slope intercept, value of intercept. The percent character acts as a placeholder for the values that are inserted in the string. These values are called in the parentheses after the string, separated by a comma, and are assigned to the variables slope and intercept. By using the CENT_F format specifier, the values are printed as floating point numbers. This allows for the easy printing of multiple variables in the same line, without the need for multiple print statements. Overall, this line of code provides a quick and concise way to display the values of the two variables in a clear and formatted manner. This Python code prints a statement stating that the r² value is calculated as the square of the r_GOR value variable. The CENT_F indicates that a floating point value will be inserted in place of the cent sign. This allows the code to dynamically insert the value of r_value2 into the statement, making it more versatile and easily adaptable for different values of r-value. Overall, this code serves as a quick and efficient way to display the calculated r² value to the user. This Python code prints out a statement stating that the standard error is being calculated, followed by the current value of the variable std_error. The CENT_F format specifier specifies that the value of std_error should be converted to a float before being displayed. Overall, this code serves as a way to display the current value of the standard error to the user. This code is calculating the predicted value for each observed value in a dataset called df. The predicted values are calculated using a linear regression model with the slope and intercept values. The residual, which is the difference between the observed and predicted values, is then calculated and stored in a variable called residual. The next few lines of code are creating a plot of the residual series using the matplotlib library. This plot is then displayed with the title residual series of the model, which shows how well the linear regression model fits the data. This plot can help in identifying any patterns or trends in the residual values, which can indicate if the model is a good fit for the data. This code uses the Python library matplotlib to create a figure with a size of 15 by 6 inches. The next two lines of code use the plt.plot function to plot the data points in the variables x and y. The third parameter O specifies that the data points should be displayed as circles. This is labeled as original data in the legend for the plot. Next, the code plots the data points along with a fitted line. The slope and intercept of the line are calculated using a regression model. The third parameter R specifies that the line should be displayed in red. This line is also labeled in the legend as fitted line. The purpose of fitting a line to the data points is to find a mathematical relationship between the two variables and to predict new data points. The following two lines add a title to the plot and display the legend. Finally, the last line of code shows the plot. This code is useful for visualizing and analyzing data, as it helps to identify any patterns or trends present in the data. It also allows us to compare the original data points with the fitted line, providing an understanding of the relationship between the two variables. This line of code calculates the standard residuals by dividing the residual values by the standard deviation of those residuals. The residuals are typically the difference between the observed values and the predicted values in a statistical or mathematical model. The standard deviation is a measure of how much the data values deviate from the average. By dividing the residuals by the standard deviation, we standardize them and make them more comparable to each other. This is useful for interpreting the size and direction of the effect of a variable on a model's outcome. The result of this calculation will be a standardized value with a mean of 0 and a standard deviation of 1. This standardized residual is often used in diagnostic plots to identify outliers and influential data points in a model. It can also be used in hypothesis testing and confidence interval calculations to assess the significance of a variable's effect. Overall, this code helps to make the residuals more interpretable and useful in analyzing and interpreting the results of a model. This code segment is used for plotting the standardized residual series of a model. The first line creates a figure with a size of 15 by 6, which is a standard size for visualizations. The second line plots the standardized residual values, which are a measure of how much the actual data points differ from the predicted values. This allows us to identify any patterns or trends in the residuals, indicating if the model is capturing all the information in the data or if there are any systematic errors. The third line adds a title to the plot, providing a brief description of what it represents. Finally, the last line displays the plot to the user. Overall, this code helps in understanding the accuracy and reliability of the model by visualizing the standardized residual values. This Python code performs a mathematical calculation using elements of the DF dataset. It first retrieves the values stored in the log AK column of the dataset and multiplies them by the variable slope. This product is then divided by the values in the log GARAN column. The result of this calculation is stored in the variable h. In simpler terms, the code is taking two columns of data from the DF dataset and using them in a mathematical equation to calculate a new value. This value is then stored in the variable h for future use in the code. This Python code prints the calculated h value for the 500th and 1000th day, using the format method to insert the specific values into the string. The values for h500 and h1000 are determined by some previous calculations or data, and the code is simply displaying the results for those specific days. The curly brackets act as placeholders for the values to be inserted into the string, and the .format method replaces them with the appropriate values. This code could be part of a larger code or data analysis where the h values change each day, and the code allows for easy and organized printing of the values for specific days. This code creates a plot of the values stored in the variable h over time. The first line, plt.figureFigSize 16:5, sets the figure size of the plot to be 16 inches wide and 5 inches tall. The second line, plot h, plots the values stored in h on the y-axis against the x-axis, which is automatically generated to represent the length of the h variable. The third line, plot title h value over time, adds a title to the plot, labeling it as h value over time. Finally, the last line, plt_show, displays the plot on the screen. Altogether, this code allows us to visually see how the values stored in h change over time. This line of code calculates the spread between two variables, df.log_GARAN and slope.df.log_AK, intercept. Essentially, it subtracts the second variable from the first variable to get the spread value. The first variable, df.log_GARAN, is most likely the logarithm of the GARAN variable in the data frame, while the second variable is the product of the slope and logarithm of the AK variable minus the intercept value. This calculation could be useful in analyzing the relationship between the two variables and potentially identifying any outliers or extreme values. By calculating and examining the spread, it allows for a more in-depth understanding of the data and potential patterns or discrepancies between the variables. This line of Python code is performing a mathematical operation using the variables spread and residual. The variable spread appears to represent some sort of variable related to the spread of data. It is being divided by the standard deviation of the variable residual. This standard deviation is a measure of how much the values in the variable residual vary from the mean. By dividing spread by this value, the resulting value will be a standardized measure of the spread, allowing for easier comparison between datasets with different scales. This line of code is likely part of a larger data analysis or manipulation process and is used to transform the data in a meaningful way. This Python code creates a new plot with a size of 16 by 5 inches using the plt.figure function. It then plots the data given by the standard spread variable using the plt.plot function. Next, it adds a title to the plot using the pl.title function, with the title calculated standardized spread over time. Finally, the plot is displayed using the plt_show function. This code essentially creates a visual representation of the standard spread data over time, with the title providing context for the data being displayed. This line of code creates a new column in the data frame df called spread and assigns the value of standard spread to each row in this column. This means that for every row in the data frame, there will be a corresponding value in the spread column that is equal to the value of standard spread. This is a useful operation when analyzing data, as it allows for easy comparison and calculation of spreads within the data frame. This code also assumes that the variable standard spread has already been defined and contains a single numerical value. This code is used to display the first 5 rows of a data frame, which is a tabular data structure used in Python for data analysis. The head function is a built-in function that allows us to view the top rows of a dataset. It is especially useful when working with large datasets, where we may only want to take a quick look at the data before performing any analysis. The output of this code will contain the first 5 rows of the data frame, along with the column headers. This can help us get a better understanding of the data and the different variables present in the dataset. The head function also has an optional parameter that allows us to specify the number of rows to display, so we can customize it to show more or fewer rows if needed. Overall, this code provides a quick and convenient way to preview and explore the data in a data frame. This line of code resets the index of a data frame named df. This means that it reorganizes the rows of the data frame so that they are in ascending order again. This is useful when the index of the data frame has become disorganized due to sorting or filtering. The reset index function takes in optional parameters such as drop equals true, which will drop the original index column and replace it with a default index starting from 0. By resetting the index, the data frame is easier to read and manipulate. Additionally, it allows for easier indexing and selecting of specific rows. This function can help optimize data analysis and make data more accessible for further data manipulation. This code first creates 3 lists with 2,000 positions each, named long, short, and closed, all initialized with the value none. Then it loops through the elements of a data frame called df, excluding the first row, and checks if the value of the column spread in that row is greater than 2. If it is, it assigns the value of the column GARAN to the short list at the same index and the value of the column AKBNK to the long list at the same index. Then, it checks if the value of the column spread is less than 0.01. If it is, it assigns the value of the column AKNK to the closed list at the same index. Next, it checks if the value of the column spread is less than -2. If it is, it assigns the value of column GARAN to the long list at the same index and the value of column ABNK to the short list at the same index. Finally, it checks if the value of the column spread is greater than -0.01. If it is, it assigns the value of column GARAN to the closed list at the same index. In summary, this code seems to be working with data related to stock market trading, using the values in the spread column to determine which stocks are being bought and sold at certain market conditions. This code uses the matplotlib library in Python to create a figure with a size of 15 by 6. The figure has a title that reads pair trading strategy and opening position points. It then plots 3 lines on the graph, representing data from the stocks for 2 different companies, GARAN and AKBNK. It also plots 2 additional points, representing long and short positions in the stock market. The O and VR markers differentiate between the long and short positions. This figure allows for visual representation and analysis of the performance of the 2 stocks and the opening positions of the long and short positions. The legend function is used to label the different data points, making it easier to understand the graph. Finally, the code uses the show function to display the graph. This code could be used by traders to track the performance of stocks and make educated decisions about buying or selling. This code is creating 3 empty lists with 2,000 elements each, titled long, short, and closed. The code then iterates through a dataset, starting at the second row index 1 and continuing until the end. For each row, the code checks the value in the spread column. If the value is greater than 2, the code assigns the value in the GARAN column of that row to the short list at the corresponding index, and assigns the value in the AKBNK column of that row to the long list at the corresponding index. If the value in the spread column is less than 0.01, the code assigns the value in the AKBN column of that row to the closed list at the corresponding index. If the value in the spread column is less than -2, the code assigns the value in the GARAN column of that row to the long list at the corresponding index, and assigns the value in the AKN column of that row to the short list at the corresponding index. If the value in the spread column is greater than -0.01, the code assigns the value in the GARAN column of that row to the closed list at the corresponding index. Essentially, the code is sorting and organizing data from the dataset into separate lists based on certain conditions. The code above is used for calculating and assigning values to 2 lists, GAR and AK. This is done by using a for loop to iterate over the values in a data frame, and then using if statements to assign values based on certain conditions. The first 2 lines of the code create 2 lists, GAR and AK, with a length of 1999 and all values set to none. Then, for each value in the range of 1 to the length of the data frame, the code checks if the spread value in the data frame is greater than 2. If it is, then the corresponding value in the GAR list is set to -1, and the corresponding value in the AK list is set to 1. Similarly, if the spread value is greater than 0 and the previous value in the GAR list is -1, then the current value in the GAR list is also set to -1, and the corresponding value in the AK list is set to 1. The code goes through similar if statements for different conditions, such as if the spread value is less than 0 and the previous value in the GAR list is -1. In those cases, the value in the GAR list is set to 0 and the corresponding value in the AK list is set to 0. This process continues for different conditions until all values in the data frame have been checked and assigned to their corresponding lists. Ultimately, this code is used to analyze and store data from a data frame into the GAR and AK lists based on different conditions for further analysis and calculations. This code is a loop that iterates through a range of numbers from 1500 to 1999. It first checks the value of an unknown variable GAR at the current number in the range. If the value is equal to 1, it prints a message that suggests buying GARAN stocks and selling AKBNK stocks on the I day. If the value is equal to -1, it prints a message suggesting the opposite action of buying AKBNK stocks and selling GARAN stocks. If the value is equal to 0, it prints a message suggesting to close the deal on that day. It is likely that this code is part of a stock trading algorithm or analysis where the value of GAR is being used as a signal for buying or selling certain stocks. This code adds 2 new columns to the existing data frame named AK Ishlem and GAR Ishlem. The values in the AK Ishlem column are all equal to AK, and the values in the GAR Ishlem column are all equal to GAR. This means that every row in the new columns will have either AK or GAR as its value, depending on which column it is in. This could be useful for categorizing or labeling the data in the data frame, or for further analysis and processing. Overall, this code provides a way to add and fill new columns in a data frame with specific values. This code creates 2 new columns named AR and GR in the data frame DF. The column AR is calculated by subtracting the previous row's value of AKBNK from the current row's value of AKBNK and dividing it by the previous row's value of AKBNK. Similarly, the column GR is calculated by subtracting the previous row's value of GARAN from the current row's value of GARAN and dividing it by the previous row's value of GARAN. Essentially, this code calculates the percentage change in value for both AKBNK and GARAN and stores them in their respective columns. This could be useful for analyzing the trends and volatility of these stocks over time. This code appears to be using a for loop to iterate through the items in a list. The list, transaction AK, is initialized with the value of 100. The for loop starts from index 1 and goes up to the length of the DF object -1. Within the for loop, there are 3 if statements that check the value of the A Ishlem column in the DF object at the current index. If the value is 1, the previous value in the transaction AK list is multiplied by the value in the AR column of the next index in the DF object, and then added to the previous value in the transaction AK list. If the A Ishlem value is -1, the same calculation is done, but with the negative value of the AR column. If the A Ishlem value is 0, the previous value in the transaction AK list is appended to the list without any calculations. Essentially, this code seems to be updating the transaction AK list with the results of a calculation based on the values in the DF object at each index. This Python code calculates the transaction prices and profits for the company GARAN. The first line initializes the variable transaction GARAN with an initial value of 100. Then, using a for loop, the code iterates through each row of the data frame DF except for the first and last row. If the value of the column GAR Ishlem for that particular row equals 1, the code appends the value of the previous transaction GARAN -1, multiplied by the value of column GR for the next row to the list transaction GARAN. This represents a positive transaction amount for the company. Similarly, if the value of column GAR Ishlem is -1, the code appends the value of the previous transaction, multiplied by the value of column GR for the next row, and multiplied by -1 to account for a negative transaction amount. If the value of column GAR Ishlem is 0, the code simply appends the value of the previous transaction. This process continues for each row in the data frame, updating the transaction GARAN list with the latest transaction amount and overall profits for the company. This code creates a plot with the given figure size of 15 by 6 inches. The plot is titled Hypothetical 100 lira invested for each stock. 2 lines are then plotted on the same graph, one representing the hypothetical transaction data for the stock GARAN and the other representing AKBNK. A legend is added to the plot to label each line, and then the plot is displayed. This Python code is a simple code that takes in a user input and checks whether the number is positive or negative. It starts by defining the function check positive or negative with a single parameter num. Next, the code uses an if-else statement to check if the input num is greater than or equal to 0. If the input is greater than or equal to 0, it prints out gram. The number is positive, otherwise it prints out the number is negative.